Hello friends, this is Jim with Science Talk. I have a story here I wish to share with you involving NASA satellites tracking changes in the Earth's water supply, and some of them are a bit unusual. Fresh water is changing around the world, and a new set of NASA satellite observations is helping scientists better understand why. A new study suggests that the changes stem from human activities as well as natural variations in the climate. Now, this is again where the statistical analysis is important, because we can then examine the contribution from each variable, each parameter, to the observed responses. So if it turned out, let's say, that the changes due to human activity accounts for 63% of the observed changes, okay, then that's saying that humans are having more of an impact. If it was, say, 31%, then and natural variations was more like, say, 68% or something like that, and say, okay, this is just all due to natural variations. So this is why I keep coming back to looking at the statistical analyses of things, because this kind of tells you what's going on. So this data comes from 14 years of observations from the US-German Gravity Recovery and Climate Experiment spacecraft mission, and the acronym spells out GRACE. A successor mission called GRACE Follow-On is expected to launch in the near future. This study that was published in the journal Nature shows that wet zones on Earth are getting wetter, dry zones are drying up. Now, you've heard me mention in previous stories I've covered how with climate change at hand, wet areas are getting wetter and arid areas are getting even drier. So this is satellite observational data that's backing up that claim. This is now what's happening. Why is this happening? It's due to many factors, including climate change, and not only that, but how humans use water and just natural environmental cycles. Besides the GRACE data, researchers incorporated precipitation data from satellites under the Global Precipitation Climatology Project. Imagery from the NASA U.S. Geological Survey Landsat set of satellites, maps of irrigation, and just reports of human activities in mining, agriculture, reservoir operations. The Landsat satellites are just so indispensable. They can tell you just about anything happening on the surface of the planet, over land, over water. We use Landsat satellite imagery to make note of when phytoplankton blooming is taking place in the oceans. And then we can estimate primary productivity. So the Landsat is just an important group of workhorse satellites, and their ongoing success just cannot be praised enough. Superb engineering. This is the first time we've used observations from multiple satellites in a thorough assessment of how freshwater availability is changing everywhere on Earth. So says Matt Rodell, the team lead and chief of hydrological sciences at NASA's Goddard Space Flight Center in Maryland. He continues, a key goal was to distinguish shifts in terrestrial water storage caused by natural variability, wet periods and dry periods associated with ENSO, El Nino La Nina. Also, trends related to climate change or human impact, such as pumping groundwater out of an aquifer faster than it is replenished. Changes in freshwater, particularly from ice near the poles, ice melting due to increasing temperatures, of course, could affect how quickly sea levels rise. Understanding these changes is also important for predicting the supplies of drinking water and land that is suitable for agriculture. For those of you who've been watching my videos for some time now, I hope you begin to get a sense of how interconnected and complex complicated the system called planet Earth is. Everything is so intricately tied together. And I have tried in my videos to convey that sense of how complicated the systems are and the complexity, and us trying to understand even a little bit of this is an extremely daunting task. But what's the alternative? We need to figure out, try to get a handle on what's going on. But because it's so complicated, there's so many unknown parameters, unknown variations, unknown interactions, that makes teasing out precisely what's going on difficult and challenging. Also makes any future predictions, even with the best modeling, it just kind of gives us an idea, but it's not definitive. I'm preparing a video now where I talk about looking at past CO2 levels and past temperatures, where yeah, we can have indications of what the levels might be, but because these are so far back in time, we can never really be sure of these levels. The error is just too great. It's just the data is too imprecise. It gives us compelling, tantalizing insights, but it's not definitive, settled upon data. So you can't just say, whoa, we know for sure the CO2 level was this amount. No, we don't. We can make our best estimates at it, but when you have big error bars around it, gotta be really, really careful. And with our modeling, we're projecting the future, so of course we won't know until that time actually arrives if the models were correct, but it can at least serve as notice for politicians, if you will, to start enacting policies to address whatever the situation at hand is. So basically what we're looking at here is what's going on with the changing water levels. We're losing a lot of fresh water, and you're going to need land and water to support ever-growing number of people. So we need land for housing, we need land for raising food, but also as we heat up the planet, there's less and less available land for these purposes. This soon is going to be some clashes over this, and it's going to be some clashes over fresh, clean water. It's sad to say, but that's where it's headed. So fresh water on Earth, okay, is located in soil, rivers, aquifers, groundwater, lakes, that kind of stuff. Greenland and Antarctica ice, it's water in a solid state, but that is fresh water. And so changes in its quantities were already predicted by the Intergovernmental Panel on Climate Change Models, the IPCC. Now, I know about the IPCC. They tend to actually, I'm just going to be blunt here, it's really more of a political body than a scientific body, even though they're incorporating the contributions from thousands and thousands of scientists. It really is more of a political body. And they tend to be extremely conservative, extremely low-balling in their estimates. Now, you don't want to go hog wild crazy and predict stuff over the moon, but but scientists do tend to be conservative in their predictions. They have a tendency to kind of lowball things a little bit, and then they turn around and act surprised, like, wow, well, it was more than we thought. Example, Greenland ice melt. Anyway, so co-author Hiroko Bodoing who's a computer scientist at Garda and University of Maryland College Park, said, "We examine information on precipitation, agriculture, and groundwater pumping to find a possible explanation for the trends estimated from GRACE. The GRACE data not only shows the effects of climate change, such as melting ice, but also shows how groundwater levels are sensitive to areas experiencing drought or high rain conditions due to natural cycles in the climate." Some examples: southwestern California. Groundwater was lost between 2007 and 2015 due to natural water cycles. Less precipitation fell, leading to less snow and surface water, so residents had to use more groundwater to meet their needs. Some zones did not appear to be affected by human activities, such as Africa's western Zambezi Basin and the Okavango Delta, which helps nourish wildlife in northern Botswana. Water storage increased every year on average by 29 gigatons between 2002 and 2016. But before GRACE's observations, the same region underwent at least 20 years of dry conditions that are attributed to natural environmental cycles. So once again, we are dealing with teasing out what are the natural cycle signals from what are the human signals. And that's where the statistical method and the modeling help to solve that issue. So basically the uptake of this is that the water use patterns are changing, the distribution of water is changing, wet areas are getting wetter, dry areas are getting drier. That's kind of the, if you distill this down to a few sentences, there, I just gave it to you. But that gives us an overview of what's happening with our water usage and supply. And one thing I did not see in the report indicated covered was accessibility. That can be a problem for people, whether they have access to clean water. And that's a whole other issue. Anyway, thank you for your time, and we'll talk soon. Hey folks, just a reminder to please subscribe and click the bell so you know when I drop a video. Please share my videos, please tell others of my channel and of the work that I do. I also hope that you will consider becoming a patron at patreon.com/Science Talk with Jim Massa, where from time to time I upload videos there exclusively for my patron subscribers. Details in the description box below. Thanks.